So let me show you the chain rule diagram. It's not hard, I promise.
Like on the test, we have to do the diagram?
No, I won't care which way you go on the test. So if I had, say, f of x and y is x squared minus y squared, and x is a function of r and theta, it's specifically r cosine theta, and y is also a function of r and theta. Oh god, how do you write? Which is r sine theta. Oh hey, those look familiar, right?
Yeah.
This is like convert to polar, right?
Yep.
Okay, and I should use the chain rule to calculate, I'm supposed to calculate the partial with respect to r and the partial of f with respect to theta, right? Oh, which says, so I said use the diagram but not direct substitution. What that means is do not just plug x of r and theta and y of r and theta in for f and then calculate. You guys see that? You should be able to do this in a more sophisticated way. Right?
That you did teach us.
No, I did teach you this.
You didn't do that.
So the more sophisticated way is for you to think, okay, the partial of f with respect to r, right, is going to be
df of dx.
the partial of f with respect to x times
Partial of x with respect to r.
partial of x with respect to r, right? So this is going to be, what I'm thinking, right, is the change in f per change in r, right? That can come out of two places. Either it comes out of x changing because r changed, or it comes out of y changing because r changed. So I'd add this to the partial of f with respect to y times the partial of y with respect to r. You guys with me on this? And then to actually calculate these, what's the partial of f with respect to x? 2x. What's the partial of x with respect to r? Cosine theta. What's the partial of f with respect to y?
Negative 2y.
Negative 2y. And what's the partial of y with respect to r? Sine theta.
So those are 2's on the bottom then? I thought those were the symbols.
Nope, those are 2's. I feel like this is going backwards in notation for some reason. Yeah, so if you look really carefully at my handwriting, you'll realize
The 2's have a tail.
that the 2's have ever so slightly longer tails, except for that one, which is a 2. Yeah, so that's unfortunately context. Sorry, my bad. Yeah, I need to figure out a better way to make those things. They're dells, so they're like a delta looks like this.
See, that's what's looking
So they're lazy delta.
Yeah, they're actually a different symbol. This is a delta, right? So these are I would put in deltas, right? But I don't actually mean change, I mean the limit of change, right?
It stops.
So we kind of go from delta to a stylized del that's a limit of deltas. Yeah, stylized meaning lazy, thank you. And wait, at the end here, right? What else should I do here? I can simplify a little bit because
2's are on each side.
Yeah. I would say do parentheses x cosine theta minus y sine or would
you can factor the 2's out. I would say that this could be simpler by taking what x is, r cosine theta, and inputting it here. Right, because this is mixed. You guys see that? This is mixed between Cartesian land and polar land, right? And this derivative should really be in polar land. Right, so kind of the right category for this thing is to evaluate the 2x and the 2y at those change of coordinate things.
So would we get points marked off if we didn't do that?
No,
It'd just be hard.
I trust that you all can do that.
So what was the chain rule diagram?
So a chain rule diagram is this thing. F depends on what?
X and Y.
X and Y, right? And X depends on
R and theta.
R and theta,
So does Y.
and Y depends also on R and theta, right? So this is a part, if you kind of label your arrows with the appropriate partials, right? And this is partial of X with respect to R, and partial of X with respect to theta. That one's partial of Y with respect to R, and that one's the partial of Y with respect to theta.
You said we don't.
Yeah, these diagrams get messy if there's lots of things. But all you need to do is find all the paths to get your partial of F with respect to R. Take F, take R in your diagram, and find all the paths that'll get you from F to R. That's one. And another one is that. And then you take these and multiply. It's just a mnemonic device. I didn't teach it to you guys because you seem to understand without it. Cool? If you want to put this in your head, have at it. If you don't, whatever. Erase this from your memory.
Yep.
Cool?
It won't go away.
And then really you should do the other one, right? 'Cause they
Yeah.
asked me for the other one, but it's similar.
Yeah, you get 0 though. Make sure.
I got
What did I do wrong?
4r squared cosine
Yeah, you should get there.
theta.
Okay.
Cool? Questions, Steele? So the reason I know you shouldn't get 0? What's this? Like, what is F?
Is
Yeah, it's a saddle, right? This is a hyperbolic paraboloid. You guys see that?
okay.
If you change the thetas, right? So here's your hyperbolic paraboloid, right? You're standing here. If you change the angle at which you are looking, will the height change? Yeah, hell yeah. So I know that derivative is not 0.
Nor is it constant.
Specifically not constant. If you evaluate at x is 0 and y is 0, right? You'll get 0, right? But it's not constant. You guys see that? Because this stuff flat spot, right?
Look the ground directly below.
Cool?
I'm just trying to figure out why I did that.
I'm sure you just flipped a sign somewhere.
Is it negative 2x r sine?
Do you want to do it? We can do it.
Negative
Oh,
4.
well, you do negative 2x r sine theta, and then the x you turn into r cosine theta.
Hang on.
Negative
That's
4r
substitution
squared
again.
cosine
Okay, so you got
theta sine theta.
2x out of partial of f with respect to x, right?
Yep.
And then you should get here
Negative r sine theta, correct?
times a minus r sine theta.
Because it isn't possible. This is normal to the entity of X.
And then you need a minus 2y
This was
times
actually
a,
r cosine.
Oh,
R
this is a
cosine
minus
theta.
2y. That was the problem. That was my problem.
And then you get negative 2
Yeah, and then you get some stuff.
'Cause it's a minus 2y.
told you, sign error. That's what all your guys' mistakes are for the most part.